In this problem, we're trying to find the global minimums and maximums of this equation right here, and we're restricted to this domain. So in order to find the maximums and minimums, we actually have to take the derivative and set that equal to 0. But because we have a couple of variables, we have to actually take more the gradient and set that equal to 0. So first we're going to do the gradient, x partial derivative. So that's going to be 2x plus y. And we're going to set that equal to 0. And then we'll do the same thing for y, which would be 2y plus x. We'll set that equal to 0. If we tried to solve for these equations, we would get 2y equals negative 2x. And if we try to plug that in there, then we would get like 2 and then negative 2x plus x equals 0. And, we'd get negative 4x plus x equals 0. So we're talking like, basically the idea is that x equals 0. And when we try to solve for this, y equals 0 here over here, we get this point that it's going to be 0, 0 is the critical point that we've discovered. That's when there may or may not be a minimum or maximum. So we're going to have to sort of figure out by using the Hessian. This is the Hessian, spelled Hessian. This is how we're going to be figuring out whether this is a minimum or maximum. Finding basically the second derivative. All right. But we have some more points that we also want to be testing too. We have this stuff here. We'll do that a little later. So first, we'll try to figure out whether this is a minimum or maximum. All we need to do is to find the second derivative. So this would be fxx, and that's just going to be evaluated at that point, 0, 0, and then fyy, again, at that point. And then we're going to have to subtract fxy, again, at that point. And then we're going to square this. And that's going to give us this variable h. If that h is greater than or equal to 0, we'll have to compare that. But let's figure out what we get here. So fxx is going to be equal to the second derivative, we'll say 2, and then evaluated at 0. There's nothing there, so it's going to be 2. This is going to be the next thing is also 2. Okay, and then we're going to subtract fxy. So we're going to take that derivative and then take the x derivative of it, which is just going to be 1. Okay, great. There's nothing to plug in here, so these things kind of don't matter too much. And then that's just squared right there, and then this is going to be equal to some kind of number. So this 4 minus 1 is going to be equal to 3. Now, it turns out that if the Hessian is greater than 0, which it is, and the second derivative of x is greater than 0, which it's this, then this is a local minimum. It's just the rule that we kind of have to follow and figure it out and blah, blah, blah. So yeah, we've discovered that 0, 0 is the local minimum of this thing. And we don't know whether it's a global minimum or maximum yet, because we also have to figure out the points here. So we have to plug in critical points and boundary points in order to figure this thing out. This 0, 0 was a critical point that we discovered from taking derivatives here, but the boundary points we have to discover from this over here. And because we have this notation that essentially saying negative 2 is x greater than or less than 2 right there, we have the same thing here for y, then we could basically create the set of points would be negative 2, negative 2, negative 2, 2, probably 2, negative 2, and then you would find like, negative 2, or 2 and 2, right? So yeah, you'd have a couple of different points there. And let's try to think about it though, because if we wanted to find the maximum point, how could we find that? All of this would have to be positive. In order for all of that to be positive, you would need both x and y to be positive, right? So that would be 2, 2. So 2, 2 would probably be the maximum right there. And if we plug that into the equation, then we would get 4 plus 4 plus 4, giving us 12. And so that's going to be the maximum right there. And we also have the minimum right there. Is there a way to get less than 0 from this by plugging in some of these points? I mean, even if one of them were negative and one of them were positive, that was the only way to get some kind of a negative out of here. this still wouldn't be enough because, yeah, so there's no possible way to get less than 0 out of these. You could try to work this out, but you wouldn't get anything less than 0. So 0 is the minimum, and that's the global minimum. There's no other lower minimum than that. And also the 12 is going to be also the global maximum because there's no other maximum higher than that. So remember that local minimums are going to be only in one particular location, so like that location or that location, but the global is going to be the entire function. So like you have to look at the whole thing and say, okay, out of this entire function, which one's the actual minimum and which one's the actual maximum. And then there's a couple of little local ones around here, but those are not the global. This is the global, and that's the global, and then these are going to be like little local ones in here. So we found the absolute extremes.